Good morning. Welcome everybody to this session on AI and data science for governance, revolutionizing public sector efficiency. I'm pleased to introduce to you Mr. Shrikant. Mr. Shrikant Velamakani is the co-founder and executive vice chairman of Fractal. Fractal is an AI firm that powers decision making for some of the largest, most admired companies on the planet. Shrikant is also the founder and trustee of Plaksha University and is the vice chairperson at NASCOM. He's a global leader in AI and analytics solution for Fortune 500 companies with over 20 years of experience and has been dedicated to enhancing decision making through data and AI while fostering a culture of excellence and innovation. He leads the Fractal Group, which includes Fractal AI, along with other ventures like Cure, Eugenie, Final Mile, Crux Intelligence, Mean Analytics, etc. And beyond his role at Fractal, he also serves as an independent director at Metro Brands, BRC India, NIT Limited, and the non-executive chairman at IdeaForge, where he leverages his expertise and network to support growth and innovation. Welcome, Shrikant, to this session. We're glad to have you.
Thank you, Tashi. Great to be here. Good morning, everyone. If you ask yourself the question, what are the most important AI breakthrough of 2022? One answer comes loud and clear. And you may be tempted to believe that it may be ChatGPT. But here I am to convince you that the answer is different. And to get to the answer, let me give you a little bit of a overall story here that gets us to the answer. Bear with me for a couple of minutes to get you to the story. The story starts in 2011. There's this gentleman on the screen here who's called Geoffrey Hinton. Geoffrey Hinton was one of the pioneers of AI in the 1970s and 80s when the whole world was experiencing an AI winter. He came up with the idea of deep neural networks and did some groundbreaking work. But in 2011, the results started showing. And Google, of all companies, decided that they wanted to hire Geoffrey Hinton into the organization. There's only one problem. Geoffrey Hinton, they did not know how to price for his services. Geoffrey Hinton had two lowly interns with him as well at that point of time. One guy on the left called Ilya Satskabar and the other guy called Alex here on the screen. Now, this Geoffrey plus two interns, they wanted to name a price for it. So Geoffrey decided to create a company called DNN Research. And there was this bidding war for what should be the price for the services, for Geoffrey's services. And there were multiple companies interested in potentially getting Geoffrey on their payroll. It was Baidu, there's Microsoft, there's Google, etc. All of them were incrementing the price by $1 million each. And this email auction took place over a number of days. When the price reached $44 million, Geoffrey Hinton said, look, I'm going to stop this auction. I like Google. I'm going to join Google. So he, along with Ilya and Alex, joined Google. And from there, it's been incredible journey for them. Alex created something called as AlexNet, which showed amazing results on image-related work. Ilya went on to found a small company that you may be knowing of called OpenAI. And now, recently, he's quit OpenAI to start a new company called Safe Superintelligence, which raised $1 billion. Anyway, this was going on. Geoffrey Hinton joined Google, and they saw some amazing breakthroughs in AI. Then, after a year or two, Geoffrey and others, one guy called Jeff Dean at Google, they decided that they want to go buy this small little company in London called DeepMind. Now, there was one problem. Geoffrey Hinton could not fly. He had this back problem because of which he had to always stand. He would never sit. And doing a cross-Atlantic flight, sitting on the chair was just not possible. So then what they decided was to just medi-evacuate him on this kind of a plane, on a medi-evacuation plane. Jeff Dean went from Bay Area to Toronto, picked up Jeffrey Hinton, and then they went all the way to London to meet this company called Demis Hassabis, called DeepMind, founded by Demis Hassabis. Now, DeepMind was a company that was just playing Atari games. It was doing amazing work on seeing if human level intelligence can be achieved, a human level performance can be achieved in Atari games by computers. And they were showing some amazing results. So Jeffrey Hinton and Jeff Dean together bought this company for 400 million pounds. This company had no revenue. So many people ask the question, is this a good idea? Why are they doing this? It turns out that it was a good idea because literally a few weeks after that acquisition, they brought the DeepMind researchers to work on Google's data centers. Now, this is a picture that you see of a Google data center. Google data centers are very energy intensive. Google consumes 1% of world's electricity. And data centers consume 3% of world's electricity across all data centers in the world. And this is rising. And the expectation is that with all the power of AI being used and the data centers being needed, 15% of world's energy might be consumed by data centers. So reducing the energy consumption of data centers was an important problem. So DeepMind researchers got working on it. And within 12 weeks, they could show that they could reduce the electricity consumption in these data centers, which are already very optimized, by 15%. And they could also reduce the air conditioning expense by 40% using deep reinforcement learning. By this, they already paid for the 400 million pounds that Google paid to acquire them. Now, they didn't stop there. And that's what brings us to the 2022 question that I started the conversation with. This team worked on uncovering the protein structures of 200 million proteins over the next few years. Now, this is an interesting problem because, as you know, a lot of the life molecules are proteins. If you think of a virus, it's a protein. If you think of a vaccine, there's a protein involved. If you think of a disease, there's a protein involved. So understanding the three-dimensional structure of proteins, which are very small molecules, is important. And how the protein folds itself into the lowest energy state creates the 3D structure, which is important to figure out what is the lock and key. If you're building a vaccine, you need that key to that lock. And that's really the idea of figuring out what is the exact structure, three-dimensional structure of a protein. The DeepMind researchers created an AI-driven way of figuring that out. That was basically the work of 200 million researchers, because each researcher would spend their entire PhD in uncovering the three-dimensional structure of one protein using X-ray crystallography. Now, what they did was, if you give an amino acid sequence, they can figure out the exact 3D structure correct up to 1 angstrom distance. And they released all of this data on July 28, 2022. You may not have heard of it, but this, to me, was one of the most important breakthroughs of 2022 in AI, because it has deep implications for how human beings will progress and prosper in the next few years and decades. They went on to do other things as well in this year, where they're predicting other structures too. But for this pioneering work, Jeffrey Hinton won the Nobel Prize a couple of weeks ago for physics, for all his work in the world of AI. You see on the left picture. And on the right, you see Demis Hassabis and the DeepMind team winning the Nobel Prize for chemistry just a week ago. So this is why such an important event of 2022 was not ChatGPT as much as it was about these three-dimensional structure of proteins. The age of AI, I'd like to tell you, has begun. And my submission to you is that it will surpass the internet, mobile, and the cloud revolutions combined. That's why every country, every government, every company has to think of this and see how they respond to that age of AI. In the next few minutes, I'd like to tell you how it is going to change the world. I will tell you that there are 3 axes in which we're seeing lots of progress. Let's see one by one what those axes are. The first axis is that of productivity. Okay, just take an example of an insurance company. This is an example of an insurance company that I have experienced with. They were handling about 3.5 million conversations per year by 500 plus different agents who were answering questions. When customers call, let's say my car has broken down, I want to know whether my insurance covers this or not. These agents have to look through complicated documents to explain and tell them what is covered, what is not covered, and help them out with the claim process. So these calls end up having a lot of error rates, almost 10% error rate in answering these calls, because insurance is a complicated matter. There are lots of supervisor escalations, and calls go on for a long time, the long hold times. So what we saw in that was, with generative AI and a solution called Agent Assist, these agents have now access to intelligence from all the documents in a much more accessible way, by which they're able to handle the calls in 15% lower time, reduce the supervisor escalations, and increase the error rate from 10% to 2%. That is the power of bringing these AI models to augment human intelligence and human agents here. Now, that's one example of productivity. The second example of productivity I would like to tell you is about in this whole area, what is now called as text to image models. These are grounds up foundation models called diffusion models. One such example here is a product called Kaleido.ai built in India. And this product, for example, we have used it in doing some very amazing work in an area called food photography. So think of any website that sells you food, any company that sells you various kinds of food products. They want to show recipes and they want to show how dishes are made with those recipes. So this is a company website which has this this picture. Now the idea is that to create this picture, it takes up to 4 weeks, because there is pre-production work, there are food stylists, there are chefs that you need to hire, you need photographers, you need photo shoots. It costs roughly 5,000 euros to create a picture like this. But what if we could use AI and you can produce that picture in just 2 seconds with all the brand guidelines being met? So that is the kind of productivity enhancement that you're seeing. So one of the first axes that I would like to talk about is how AI will deliver breakthrough productivity gains across everything. No matter what human activity is involved, AI can augment human activity, improve our productivity, get more done in less time across every aspect of life, business, and society. That is the amazing implication of AI. And it is one of the ways in which GDP of the world will increase, because GDP increases by labor growth and productivity growth. If labor growth is not going to happen for the next 20 to 30 years, the world is not growing in its labor force, populations of the world may decline, then we need productivity growth. And AI is the most promising productivity enhancement technology out there. And with AI, the areas where you're seeing the maximum value are things that are cognitive and repetitive. Cognitive or creative and repetitive. That's where you see the most value being created. So think of all the kinds of activities that happen inside a government, inside organizations, which are repetitive and cognitive in nature. There are a lot of those. And each of those areas, we can see 10, 20, even 50% improvement in productivity. One example is the software industry, where writing code has been completely augmented by AI now. So you can use AI to write code. You can use AI to do data science. You can use AI to really improve the effectiveness of improve the speed of everything that we do. So that's the first axis that I'd like to talk about. Now let's come to the second axis, which is about bringing in new intelligence, bringing in new smarts to the process. I'll take you back a few years to COVID-19. If you remember how chaotic it was, I'm sure many of you were involved in helping India navigate this extremely difficult, challenging time. Where the problem kept changing. Initially, it was about tracing arrivals. Then it was about containing upcoming hotspots. Then it was about making sure that there is enough capacity for the healthcare services to be rendered, and making sure that people are not dying. And then how do we unlock after the lockdowns? How do we unlock in a safe way? These are all the kinds of problems that we encountered in 2020 and 2021. Each of these areas, we saw that we could bring in a national pandemic data platform and help doctors, city administrators to make decisions around these things, creating jumbo centers, creating oxygenated beds, understanding who has more likelihood of dying because of the disease. These are the kinds of problems we could solve through data science and AI and help the Indian government. City of Mumbai, city of Bangalore, Karnataka. I saw personally how these cities actually used AI. One of those things was to work with the city of Mumbai. And there was a panel of 10 doctors that was appointed early on the pandemic who were in charge of the city's response to COVID-19. And one of the things that we saw very early on, as early as June 2020, was that using the mortality data, we could find out that people who have hypertension have a 28% higher likelihood of passing away through COVID. Whereas diabetes increases the risk by 303%, tuberculosis by 275%. So seeing this information and briefing the panel of doctors that was handling the city of Mumbai helped them in getting the first understanding of what are the mortality drivers of COVID. And this was very, very helpful. So AI can make a big difference by bringing in intelligence in the data and bringing it to the users who are making these decisions in real time. So we saw that close at hand. Lately, we one of the platforms that's come up is called Vaidya.ai. It's India's chat GPT for healthcare. And the idea here is, can I ask any health questions? Can I upload any document, medical reports, and get really good advice? Help me prepare to a doctor's meeting or understand what the doctor has told me and understand the side effects of medicines. This is the kind of thing that is beginning to happen. Vaidya has been trained on India's examination called PG NEET, and it actually gets a rank of 500. There are 200,000 applicants taking the test every year. We tested Vaidya on 20 years of PG NEET exams, and it gets a rank of 500, and it beats many of the popularly known AI tools out there like GPT-4 handsomely. And it answers very interesting questions, and it creates, it's really going to augment doctors, and it made augment doctors, it's also augmenting patients and people, ordinary people like you and me, in order to make better healthcare decisions and get better healthcare advice. Just to give you one more example of healthcare and what it can do, this is a very favorite example of mine, even though it's a little old now. After a week after GPT-4 was released in March 2023, this gentleman, P. Cooper, he basically talked about how his dog was saved with GPT-4. This dog was dying. It was anemic. He had consulted many vets, no solution. He went to ChatGPT, GPT-4, and he asked GPT-4, what could be going on with my dog? Here are all the medical reports. He uploaded these medical reports, and then GPT answers, hey, I'm not a vet, but these are a couple of the hypotheses that I have. And one of those hypotheses that is highlighted here is hemolysis. He took this hypothesis back, went to the vet, and the vet could see it and say, hey, my God, I didn't even think of this, and then put the dog back on this kind of drug therapy and cured the dog. So we have a real possibility that healthcare can be dramatically impacted if we can use all these medical foundation models or general foundation models built for medical purposes and augment doctors, augment insurance companies, augment patients in order to make better healthcare decisions overall. It has huge, huge potential for a country like India, which has huge number, a 1.4 billion population. We don't have sufficient doctors. We don't have sufficient radiologists. This is game changing in that world. Now, I'm going to talk on the intelligence theme. I'm going to show you now one little video of something. Just bear with me for a minute to watch this video.
Well, it's finally happening. The robots. They're coming.
Hey, Angry.
Maybe that's a good thing.
Said what? She said what? What are you talking about?
We are now connected to our plans.
It drives better than you do, babe.
Hi, robot.
Now, we may have thought of autonomous driving as one of those holy grails of AI, and it is already real. Waymo has now been doing these rides, 100,000 plus rides, completely autonomous, where the passenger is not expected to take control of the vehicle at all. Completely autonomous, 100,000 rides per week. And it has shown that there is a 73% reduction in accidents across the cities of Los Angeles, San Francisco, Austin, and Phoenix. So you can see how powerful these models can be, because now this intelligence is there across the board. Waymo is focused on building one intelligent driver. Just imagine if you can build one amazingly intelligent driver. Now you can copy paste this driver across all cars of the world, and suddenly we would have so many accidents and so many deaths can be prevented by something like this. That's the power of AI. And this is the second axis that I was talking about, that this foundational layer of knowledge and intelligence will be embedded in every aspect of our life and every product, service, and process. Just imagine everything getting smarter because we have this ability to take this intelligence, train doctors, train this AI radiologists, train this AI drivers who will then help us in navigating the world and get better outcomes for the world. So this is the second axis. So far we talked about productivity. Second, we talked about this knowledge and intelligence. Now we're going to the third axis, and this axis is about user experience. So let's see a little bit about what this user experience could look like. Now just think of, this is something that Microsoft released about a few months ago. I mean, they released a paper, they haven't released the software. But what they've shown here is that if you take a single image, like you see on that screen, and you attach it to an audio clip, it will make the audio clip on the image and create a video out of that, and see how it plays. I'm going to play the video for you shortly.
So, sometimes nothing happens, and sometimes everything happens all at once, and you just got to deal with it. And it's also just strange to both be extremely worried about different things and have your anxiety levels like peak to the highest.
You can see how amazing that is, how beautiful is not just the words, but also the expression, the eyebrows, and everything moving according to how the video should play. Right. So the idea of taking an audio clip and making it a video, that's quite impressive as to how much more usable, how much more easy it is to watch and understand compared to just pure audio. Right. Take this other example, which was released by GPT-4 earlier this year. Now, this is a visually impaired person. Let's see how he is navigating the world.
Is the king in residence at the moment?
Yes, it looks like the king is in residence right now. The royal standard flag is flying above Buckingham Palace, which is the signal that the monarch is present. How exciting to be there while the king is home.
Try and tell me exactly what they're doing right now, please.
Right now, the ducks are gently gliding across the water. They're moving in a fairly relaxed manner, not in a hurry. Occasionally, one of them will dip its head under the water, probably looking for food.
So you can imagine how this changes how we navigate the world. The user experience of technology is dramatically changing. This one last example, this is me, Srikanth, recording for an AI masterclass. So let's see how it goes, okay? Just bear with me, just 1 minute. You'll find something very interesting at the end of this.
Hello, everyone. Unlock the incredible potential of leading with artificial intelligence. Welcome to Beyond ChatGPT, the AI and generative AI masterclass for CEOs. Whether you're looking to integrate AI into your enterprise or enhance personal productivity, this session is for you. You will leave with the essential knowledge and tools to apply AI, both in your organization and your everyday life. I'm Srikanth, co-founder and executive vice chairman of Fractal. Actually, I am Srikanth's AI avatar, and the real Srikanth, who you can see behind me, wanted me to handle the start of this session. I think he is getting a bit impatient now, so I'll hand you over to him for the rest of the session.
You can imagine what it means. It means that now once I have recorded, I've given my voice and video samples to somebody, now we don't have to record my videos anymore because the AI avatar can do the entire masterclass by itself. It can take the content and present like me in a seamless way, which means that we don't need photo shoots. We don't need me to be present. We don't need photographers. We don't need lights. We don't need the equipment, nothing. The whole video can get produced. So it can not only dramatically improve productivity, but also means that instead of waiting for my time, this time my AI avatar can do this job. So think of all technology and how it can become much more human-like in the way we see it. So AI will make our user interfaces much more human-like and natural. So that is my third submission to you. So productivity, intelligence and knowledge, and user experience. These are the ways in which AI is really dramatically shaping our world. Now, we know that whenever some new technology comes to the world, it is met with skepticism. Whether it's a printing press, or it's a telephone, or it's the internet, we all thought, you know what, it's a bad thing. It'll create more harm than good. But it's over a matter of time and a period of time that we realize that, yes, we can control the bad outcomes, and the good outcomes will change the world and move the world in a positive forward way. But therefore, in the similar way, I believe that AI will be there for good, changing our lives and making our lives better. Now, why is this tech very different this time around? Number one, for the first time in the hundreds of years of technology, we have a technology that really understands us. You can speak in Marathi, or you can speak in Bengali, you can speak in full sentences, you can speak in half sentences, you can have fully formed thoughts or half-baked thoughts. No matter what, it will get you, it will understand you, meet you where you are, and help you, as opposed to any technology that involved you learning it first. This technology will learn your behavior, number one. Number two, it's responsive. It will learn in the course of a conversation, it can get better. It continuously improves itself, or so it seems. And that also is a very good user experience for people, because it takes feedback and improves the responses to you. And three, it has the compressed knowledge of the world. It's very powerful. Never has any technology, with the possible exception of Google, has all of the knowledge of the world in one place that it's leveraging to answer my questions, to help me to do stuff. That is the power. So these are three reasons why this time this tech is different and it's game changing. Add to that, it's getting better every day. And that is why we have to all pay attention as governments, as countries. We have to make sure that we are helping the country along the path of AGI. I know we have complaints that we wanted AI to do the basic stuff, the laundry and the dishes, but it's doing the high-end stuff. And that is sort of surprising and confusing for people. Why is it not able to do the most manual, tedious stuff? I thought AI is going to replace manual labor. It's actually replacing creative and cognitive labor. And that's essentially because of what is called as a Moravic's paradox. So whatever evolution has had time to work on, those are things that are harder for AI to learn. But things that are more recent in evolutionary path, they're easier. So now AI has succeeded in essentially automating everything that requires thinking. But what we do without thinking, those are the hard problems for AI. And that's called Moravic's paradox. And that's really, there's an evolutionary logic to it, that some of the reasoning and conscious tasks have only been around for 10,000 years, whereas some of the more sensory motor tasks have been around for millions of years, and those are harder. Even there, you see Tesla's new robots that are beginning to show some serious progress, and soon we will have this robotics plus AI coming through. But for now, the biggest progress is happening in the creative and cognitive areas, like we talked about earlier as well. I'm going to give you a very, very quick overview of AI, and I'm going to try to do it in about in 7-8 minutes, and then we can get to the end of this discussion. AI is a broad term. Everything that can match or exceed human performance on a cognitive, creative task, I'll call it AI. Within that, we have machine learning, which is machines learning with data directly, rather than learning with human input. It's about learning with experience. It's not learning by rules. Deep learning is a specific subsegment of deep neural networks. And within that are these things called large language models or diffusion models, which are the new technology within deep learning, which is very exciting. And data science is a sister discipline about using data to drive decisions. These are all sort of related in this way. Okay. Now, AI started 50, 60 years ago with humans instructing machines to do exactly what we wanted them to do. For example, when Deep Blue defeated Kasparov in 1997, it was because of rules, chess rules that it had learned and ran those computations faster. It was not really learning with experience as much as it was learning from chess grandmasters instructing it to do something faster, better, and cheaper. But now we have machines that can learn with experience with data. Supervised, which means with examples, labeled examples, like a cat is a cat and a dog is a dog. And after looking at multiple examples of cats and dogs, figuring it out. Unsupervised, which means that there's no labeled examples, but I look at patterns in data and see what is usual, what is unusual. And reinforcement learning, which is like game playing. I make some decisions, I get some feedback, I learn, I get better. And then we added something called a self-supervised, which is about sort of in between supervised and unsupervised, which is how ChatGPT works, which is about, it takes a series of text, predicts the next word, and then sees what the actual word is and learns in the process. I'm going to show you a little bit as to how it works. But before we go there, I just want to tell you how this thing works and what is underlying this deep progress in tech that we're seeing. It's about reducing error rates on the left side of this equation. And it's a combination of massive amounts of data, lots and lots of computational horsepower, and better and newer techniques like deep learning and large language models and attention, etc. So this is really the combination, the exponential combination of these three. Each of them are exponentially getting better with time. When you multiply that, you have these extremely exponential wave that is happening, which is way beyond Moore's law. Now, data sizes are multiplying. And ChatGPT was built on lots of data, like 1400 times, 1200 times of Wikipedia. Llama 3.1, 3.2 are built on some at similar data sets, sizes, incredible amounts of compute. An Azure supercomputer was built for this, and it was trained on 285,000 computers linked to each other and 10,000 GPUs to train these models. These are very powerful models trained over 30 full days at a stretch. So you switch it on, train for 30 days, and at the end of 30 days, it gives you the first answer. That's how these models are trained. Highly energy intensive and highly computationally intensive, trained on 10 trillion words. So data and compute. In terms of technique, some technical improvements happened, like attention paper, which was released by Google in 2017, and large models, where the number of parameters or number of things you can tweak have dramatically improved. GPT-4 trained on 1.8 trillion parameters, or things that you can adjust to get the right answer. Those are called parameters. Think of a pilot of a plane. How many knobs can she or he adjust to get the right flight path? This is exactly what's happening. These are the 1.8 trillion knobs that GPT-4 uses to get the right answer. That's about larger models with better techniques. Now, how does this work? To give you a sense of that, we took this very famous book, which The Boy Who Lived, Harry Potter and the Sorcerer's Stone or Philosopher's Stone, and we took the first paragraph of that, and we masked out a few words. So the words that you see in black, they are masked out. Now, this is how this model works. You give it this text and ask it to predict what would be that word, what estimate or guess what the word would be. And then when you get the right answer, great. But if you get the wrong answer, it takes and learns from it. So let's see what it does. So let's see, now when you ask GPT and say, hey, what would be the word? This on the left panel, you see what the guess would be. Now it's guessing that the first word is perfectly with 70% chance, entirely as 20%, and completely as 10%. Let's see what it does. The actual answer is perfectly normal. So it is perfect. It has got this right. Now let's look at the second word. Here, it accurately predicts that it should be strange. And third, it actually predicts that it should be beefy man. And finally, here is where it gets wrong. For some reason, it gets it wrong. Instead of mustache, it's somehow got it wrong. Maybe partly because of the way we may have given the picture, but it gets it wrong. But anytime it gets it wrong, it takes its feedback and learns from it so that it gets better next time. And finally, last one, again, it's right. So this is the technology, this is the underlying technology of how these models work. So I've given you a very, very quick whirlwind overview of how these models really work. And to tell you that this is not, it's so fast, it's so exponential that it can be deceptively, it may feel deceptively slow in the beginning. The example that comes to mind is how the Indian mathematician who invented chess, when he went to his emperor, this emperor was very happy that he found this game of chess that was invented. So he said, the emperor said, you know, I'm so happy with you. Ask me anything. I'm willing to give you anything. This mathematician says, sir, I'm a simple man. I have simple needs. Just give me 1 grain of rice for the first grain of the chessboard, and then keep doubling it for the next 63 squares. The king says, or the emperor says, this is such a small ask. This doesn't make sense. Ask me something bigger and more. He said, no, this is okay for me. And for the first 32 days, it keeps happening. And by the end of 32 days, already 100 tons of rice have been given to this gentleman, to this mathematician. And the king is thinking, okay, it was more than I expected, but 100 tons, I can afford it, no problem. But then if you go all the way to the 64th square, you get to 429 billion tons, which is 5 times the annual production of rice across the world today. So not when the chess was invented. The exponential trends multiply so fast that we are not able to, as human beings, able to see that 100 tons can become 429 billion tons in 32 additional moves. But that's how the second half of the chessboard is so much more powerful than the first half of the chessboard. And ladies and gentlemen, I hate to tell you this, we have entered the second half of the chessboard. And if we don't pay attention, things will move very, very fast and we will be caught blindsided. Now, how does a government respond to an opportunity like this? To me, there are 4 key vectors. Number 1, we have to facilitate this rise of AI, which means that we have to create the conditions by which companies, entrepreneurs, startups and universities and people with ideas can go and do the stuff and do the best work that they can. How can the government facilitate that? We have a national AI mission, which is already enabling some of that. The 10,000 crore mission is creating GPU capacity. It's investing in startups. We're doing things like that. We are creating use cases. This is the first aspect, which is facilitate AI and the development of AI in the country. I think we are already on that path. The second one is leverage, because governments have vast amounts of data, massive amounts of data. How can I use the data of the government in order to improve the functioning of the government? And how do I leverage the value of this data? We saw some examples of pandemic and what the government did. How can we bring it to the national health mission? How can we bring it to a whole host of other ideas and big ideas that we have, whether it's at BPIs and other places? How do we leverage this to make better decisions? That's the second idea. And here, for example, India has open government data initiative. How can we take all of these kinds of initiative to the next level? That's the second vector. The third vector is preparing the country. There is disruption. If we think GDP per capita is going to increase and productivity is going to increase, it means that there could be jobless growth. It means that there could be disruption in some of the most important sectors of our economy. How do we prepare the economy for disruption? How do we prepare the economy for the onslaught of AI? And if India is a net provider of labor to the whole world, how do we make sure that in a world where capital becomes more dominant, how do we prepare the country for it? How do we reskill our population? Half-life of knowledge is 3 years or under. How do we make sure that the national skilling mission, those are the ways in which we prepare the country for this AI wave? And finally, in terms of governance, this is super important. AGI is going to be here. AGI is artificial general intelligence. The day machines will beat human beings in every aspect of performance. We are pretty close to that, but maybe 3 to 5 years away. But if that is going to happen, this powerful AI could be used in autonomous weapons. This could be used for cyber security or cyber hacking. It could be used for creating competitive advantage at a level where countries that don't have AGI could really lose out. So how do you create the path for AGI for India? How do you govern that? Maybe create a department of AI that can, like ISRO or Bhabha Atomic Research Center, create India's response to AGI. That's the kind of governance mechanism we can create. And the last point on governance I would not like to make is the idea of responsible AI. AI is powerful, but it has to be responsible. And I know all of you are well aware of that, but there are possible responsible, there's a lot of thinking that's happened in creating the principles underlying a responsible AI, whether it is being planet inclusive, whether it's bringing in fairness and equity, or robustness and stability, and making sure that it's transparent, it's accountable. These are principles that have to be involved in every AI system that's created in India or used in India. That means that there are some behaviors and some enablers, some ways to check whether this is happening or not. So just to give you one little example of how this can be done, I'm going to give you the example of Cure.ai. So initially when we built Cure.ai, this is a healthcare AI company. And what happened here was AI is a black box. It would take an X-ray and tell you that something is wrong with the X-ray. But if you asked it, where is it wrong, it would not be able to explain itself. So this is a way in which explainability was created here. So imagine this is the original image on the left here, which has a little patch. If you see below the red patch, it is the patch which is pleural effusion. There is something happening on that, which is a very dangerous condition called pleural effusion. Now, how can AI detect where the problem was is done by this rectangular black block that you see that's moving in the second image. Now, when it's going through that image, it is occluding or preventing the AI model to see part of the image. When you see that it goes through this area on the left of the chest here, the probability drop on the right drops down, thereby telling you that is where the problem is. So this is how we build in explainability features into AI in the case of Cure.ai. But I mean, this is a very important topic. We have to make sure that India has a robust responsible AI framework. As NASSCOM, we built the responsible AI framework for India that India is already beginning to use. So this is how we make sure that the rise of AI is governed appropriately by the government. I will use that. I'll stop here right now and take some of your questions.
Great. Thank you, Shrikant. We'll take a couple of questions now. I will read out a couple of questions for you. The first one that we've gotten from the audience is, can AI replace creativity? In other words, can perhaps AI generate feelings, emotions, or something of that sort on demand?
Yes, AI is already pretty good at reading emotions. If you, for example, give it a picture and ask it to read what the emotion of the person involved is, we can argue that sooner than later, AI will be even better than human beings in doing that. So we clearly seeing that AI can detect emotions. AI can also bring the right emotions in the conversations. So it can, for example, it can, what it can do is it can make sure that the conversation it's having with human beings brings the emotion, empathy, caring, even more so than we human beings can do. For example, if you think of elder care, eh, as people get older, they need, they seek companionship, and their next generation, younger generation, may not be there to provide that companionship. So how an AI tool has the ability to go listen to them, spend time with them, and even be their emotional support companion. So sooner than later, we will see that AI will do an equally good job. Whether we human beings will, take to those kinds of AI or not, it's an important question. I don't think we can sufficiently answer that, but it is entirely possible that we will fall in love with AI, like the movie Her that we saw. I know I have had some trouble in using my camera, but I'm going to switch it on again. Sorry about that.
Sure. Thank you. Another question is, in a sort of apparent arms race towards AGI, artificial general intelligence, and a more and more powerful model, there's also an increase in energy consumption, and perhaps there's also a simultaneous race towards building energy infrastructure, because it's believed that perhaps whoever is able to build the infrastructure will be able to also achieve AGI. So, how do you think innovation in perhaps the energy space is also going to be just as important as the further innovation in AI?
Absolutely. These AI models are energy intensive. So one of the examples that's been talked about is to train a foundation model once. This I showed you this 30-day training period, right? The amount of energy consumed in that 30-day period is equivalent to the lifetime carbon emissions of 5 cars. So that's the amount of energy consumption that is happening. So number one is that one way to think about is that if these models are built once and can be used multiple many times, so in that sense it may be still okay to train these foundation models because they can be used millions of times, billions of times, whereas a 5 cars for the lifetime is just 5 people using that car, right? So in that sense it may be justifiable. But the second point is much more important, which is that there is a lot of work happening in reducing the energy consumption of these models. And whether it is coming up with various efficient ways of training these models, inferencing these models, the energy consumption that is currently happening, as we get better and better techniques, we will dramatically reduce the energy consumption. Already since 2022, the energy consumption involved in training these models has already come down. So it will come down further. And the third axis is that we are working on, everybody in the world is working on finding out other alternate energy consumption, energy mechanisms, so that we can feed the increasing demand for energy across the world in every aspect of our life, but specifically for AI as well.
Great, thank you. Next question is can you perhaps tell us how we can ensure that AI systems used in governance are free from bias and provide fair outcomes across diverse populations like that of India's?
Yes, I will do that. Can I just try to see if I can restart my browser so that I can
Yes, please. We'll just take a moment.
Okay. Are you able to see me by any chance? No, right?
No.
Okay. Sorry about that. Okay. Yeah. How do you make sure that we reduce biases in AI models, right? That is specifically in the model that the government is using. So first of all is the underlying data. So we have, like I was talking about, the responsible AI framework. There's an evolved responsible AI framework that starts with making sure that the data that we're using is representative of the population that it is being used to work on. So that's something that we have to do. Secondly, the process of creating these AI models, we have to make sure that there's a lot of human intervention in the process. There's a lot of training and tweaking and validation. For example, some of the work that you saw of GPT-4, etc., it involved human feedback. This and supervised fine-tuning, things like that, which are technical in nature. I'm not going to get into that for right now. But in each of these types of things, there's human input involved to make sure that the human input is coming from a diverse set of voices and not from one set of voices. If it's all of them are young men in their 20s sitting in the Bay Area and building these models, you know that the models will have some bias which involves what they think is good, right? So that is the kind of issue that you may have. So you have to make sure that not just the data source, but the way it has been trained is there. And the next thing is that you have a model, then you are going to validate this externally and actually make sure that each aspect of the response, each principle of responsible AI is measured and scored. So we should be able to see it. For example, every AI product that's been released is scored on a responsible AI framework across each of these principles with these toolkits. And overall, it is released only when it is green on that scorecard, right? So you can actually create that scorecard, and then you release it in the public. But once you have released in the public, you'll have one more set of validation, which is that some people will play around with it and find issues with it. To be able to perfectly capture what is not going right, because no matter how well you plan, something could go wrong. To have an ability to receive that feedback and then quickly incorporate that into the next version, the next iteration of the model. So the entire process from data to how we process it, who's working on it, to how we validate it, to how we launch it and how we take feedback and work on it. In each aspects of that, the entire responsible AI framework has to be applicable. And that is how we can make sure that AI is responsible and usable by everybody. Because the good news is that if more and more people are using, you will also find all of those corner cases, so to speak, where AI is not working, and then use that constructively to improve the model. Now, this is still not a perfect solution because no AI is currently perfect. But this will do the trick for most of the times, for most of the problems. And then last point I'll mention here is that to create AI could also have catastrophic large outcomes, which could be bad. So you stop those kinds of outcomes by creating what I call as the AI safety process, which is like a big red kill switch, that if this AI is going out of control, I should be able to press that red button and kill everything. So that should always be designed into the process of building any powerful AI. Now, we don't have any AI today that is that powerful, but soon enough we'll have that AI. And therefore, building AI safety is also the way in which you can make this AI more responsible.
Thank you. I think we have another question, which is, I think, perhaps a common concern, which is, how do you anticipate AI affecting employment in the public sector? Will there be job displacement? And how can we upskill and reskill affected people?
Yes, that's a great question. And I'm actually alluding, I've been watching some conversations happening in the US about what sometimes is called as the deep state and how the administrative bureaucracy is very large. It's a very active conversation in the US. And one of the presidential candidates who dropped out recently is Vivek Ramaswamy. I saw one of his interviews with Lex Friedman, where he was saying that, you know what, I should eliminate bureaucracy by 75%. And his plan was very simple. Take the social security numbers of all the people and all odd-numbered social security numbers, just fire them. And the government will still work. And then take the remaining half and then fire the other half. So some of these kinds of statements are coming through, which is not related to AI, but there is definitely this sort of expectation that the throughput or the productivity and should go up for the country with AI, and therefore, if each one of the parts of our administrative infrastructure uses AI, I think we can drive these incredible outcomes. So the best way to frame it is to actually see how can we increase throughput with having the same team. But it's entirely possible that parts of jobs are automated, parts of tasks are automated, and therefore we don't need as many people to do the same thing. So like I keep saying, humans who use AI will outperform or even displace humans who don't use AI. So it is imperative that everyone who in the employment market should get familiarized with AI tools, learn those AI tools, and use them in improving their own effectiveness, because sooner than later we'll all be using it. It's like using spreadsheets and Excel spreadsheets. Maybe 25 years ago or 30 years ago, people would have thought, you know what, these spreadsheets are a new thing. I don't know if I really want to use it. Or this internet thing is a new thing. These smartphones are new. Or this Zoom and Google Meets are new. Anybody who resists new technology eventually gets, unfortunately, affected by the rise of that new technology. So what we can do is to make sure that we embrace this new tech, learn it, and be the best, most productive users of these technologies. That is the best antidote to the rise of these technologies and displacing jobs in the process. But the jobs will be lost. There is no doubt. It's about how do we reposition, redeploy people in a way that is most effective in the world where we'll have breakthrough productivity gains through AI.
So we'll take one more question, which is, so with the increasing use of AI in public systems, how do we strike a balance between effective governance and the right to privacy and freedom from being from excessive surveillance?
I keep referring back to what I call as a newspaper test or the YouTube test for more younger audience. The idea that if we can safely publish, if a critical newspaper reporter were to write about that in a national magazine or show it on YouTube, we should be comfortable with it. That in some way is a smell test of AI and making sure that, look, it's still okay. Yes, there are some aspects of government which are deeply important and have huge security implications, which I'm sure the government cannot expose to all the individuals, all the citizens of the country. But by and large, 99% of what the government does can be transparent in a way that a critical newspaper reporter could write about it, and we should be comfortable in that world. So that's one test of keeping AI responsible and making sure that there's privacy along with effective governance. When in doubt, when this newspaper test fails or the YouTube test fails, it means that we have moved from the good part of the governance to creepy part of the governance, which involves too much surveillance. So this is an ongoing question, and it is something that citizens must have a voice in. This is my opinion. Again, I'm one person with an opinion, but this is my opinion on this topic.
Right. And just we'll tie it all up with one final question, which is what sorts of regulatory frameworks do you think are needed to ensure that AI implementation in governance is ethical and also maintain public trust in these AI systems?
Yes. Number one is to have a responsible AI framework along with its toolkits and behaviors and toolkits that is set up, which could be self-governed. So it is not, I don't think it's feasible for the government to monitor every single AI product out there. Every product will have some AI in it. What we can do is to make sure that there is a responsible AI self-certification mechanism for anything that has any power. So anything that has more than let's say, touches more than 100,000 lives or maybe 1 million lives, the threshold could be set accordingly, or is a company that's big enough in terms of revenue, if they are publishing a product, it should be self-certified through this responsible AI lens. Therefore, there's an adequate documentation that processes have been put in place for it to be responsible. So it doesn't have to be a regulation as much as it's a self-governing responsible AI framework. That's one. Two is that there are some human evaluations, what are called as human evals, we can create for really powerful AI. Now, this is for all AI, but some AI is extremely powerful, which has security implications, national security implications, or other implications, which are very important. And those situations where AI is very powerful, we may have some additional regulation in terms of how it will be deployed on humankind, in the world, etc. So there could be the path to AGI. When we feel like we're making progress, how do you make, maybe there could be some restrictions imposed on some of this technology. You can see an example of that last year, year before last, when NVIDIA announced its H100 and then H200 chips. They were banned from export to certain countries because of this fear that this would help them in matching up or leapfrogging on AI. So if there are sufficiently powerful technologies that are coming in which give breakthrough gains and could have national security implications, we may have to make sure that these things are controlled, and not everyone has access to uranium, as an example, because it's too powerful. What part of what powerful AI could be as powerful as that? So therefore, we need to control. I think regulation does make sense, and creating these safety mechanisms within AI will make sense. So that's at least a two-pronged solution that I think will work for India. That's, again, my opinion.
Thank you. Thank you, Mr. Srikanth. And with that, we will also wrap up the rounds of questions. And that brings us to the end of this session on AI and data science for governance. I'd once again like to thank Mr. Srikanth for taking up the time for this session and for your wonderful insights. And thank you to everyone else for being a part of this session and watching along. Thank you.
Thank you.